cost in dollars of producing X belts is given by C of X equals this function. The revenue in dollars of producing and selling X belts is given by R of X equals this. We want to find the rate at which the average profit is changing when 196 belts have been produced and sold. Okay, so average cost is your total cost divided by X, the number of items you produce. Average revenue is R of X divided by X. Average profit per item that you produce is what that means. It means average profit per item is your total profit, P of X, divided by X. So we're not given profit, but we're given revenue and cost. And profit is defined as your revenue minus your cost. So we have R of X is 42x to the 4/5 minus, I'm going to go ahead and distribute the negative out over C of X here. So minus 971 minus 18x plus 0.076x squared. And it's all over X. So this is the average profit per item produced. Now we want to find the rate at which this is changing. When you want to find the rate at which something is changing, that means you need to differentiate. So we need to differentiate the average profit per item. Something I did not do in class, but I did do in pre-cal, you may or may not have seen, is to call average profit P bar. Okay, you really don't have to, it's just, it gives you then a way to write the derivative. I'm going to write the derivative of P bar, or you could write P bar prime of X for derivative of average profit. Except actually, you know what, I don't want to differentiate that yet because I would like to simplify it first. So let's call this P bar. So P bar is, okay, if we differentiate it right here at this step, then you've got to use the quotient rule, which is fine. It's just a little bit longer. So instead, I'm going to split it into 4 fractions first. Got 42x to the 4/5 over x minus 971 over x minus 18x over x plus 0.076x squared over x. Okay, I'm unsimplifying average profit by unsubtracting and adding all the terms, splitting it into 4 terms. And let's go ahead and simplify each of these terms individually. That one's easy, those x's cancel. This one we have x to the 4/5 divided by x to the 1st. Exponent rules say that you subtract the exponent in the numerator minus the exponent in the denominator. So we have 42x to the 4/5 minus 1 is 4/5 minus 5/5 is negative 1/5. Minus 971, let's write that as x to the minus 1 there. Minus 18. And then one of those x's cancels, so you get 0.076x. Okay, that's what I want to differentiate. So I'm going to find the derivative of average profit. I'm going to differentiate this right here. So we'll have negative 42 times a 5th is negative 42 over 5. X to the negative a 5th minus 5/5 is negative 6/5. Then bringing this minus 1 down times that minus 1, we get plus 971 x to the minus 2. The derivative of negative 18 by itself is 0, and the derivative of the last term is the coefficient, 0.076. Okay, so there's the derivative of the average profit function. We actually want to find the rate at which the average profit is changing when 196 belts have been produced and sold. So that means we want to find the derivative of average profit at 196. So P bar prime of, can't write, P bar prime of 196. And you'll have to enter that on your calculator. Okay, entering all that in right here, I got 0.08636. Let's go look at, what does that mean? 0.08636. Let's round to 4 decimal places, so about 0.0864. Okay, the units. A derivative is a rate of change of the function with respect to x. So this is it's always the rate of change of y with respect to x. So it's always going to be units of y divided by the units of x. So in this case, the y, the units for p bar are dollars, and the units for x are number of items, or in this case, belts. So that's how many dollars per belt your profit is changing by with each belt that you sell.